Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 7.5, which is applying the Pythagorean theorem. And we're going to be applying the Pythagorean theorem to the distance formula as well. Okay, it can be found on pages 320 to 321. So let's talk about the nuts and bolts of the Pythagorean theorem, what we know. We know that the Pythagorean theorem applies to right triangles only. Right triangles only. And when we have a right triangle, the two sides that make the right angle are called legs, and they're represented by an A and a B. Now, the side that is opposite of the right angle, this is also the longest side. This is the longest side. It's called the hypotenuse. And hypotenuse. And we use a C to represent the hypotenuse, or the longest side. Okay? So the two sides that make up the right angle are called legs, and we use an A and a B to represent those. The side that is opposite of the right angle is always the longest side, and it's the hypotenuse, and we use a C to represent that. And we know that with right triangles only, that A squared plus B squared is equal to C squared. And in the past, we've been given right angles, and we've had to use this formula to find the measurement or the length of the missing side. Okay, so they would give us both legs, and then we had to find the hypotenuse, or they would give us a leg and a hypotenuse, and we needed to find the other leg. When we've used this in the past, it's always been, they've given us the right angle. We know it's a right triangle, and we're using that to find the missing side. Well, today, they're going to give us a triangle with all the measurements, and we need to decide if it's a right triangle or not. So they've given us this triangle. They've given us the measurements of all three sides. And they're asking us, is this a right triangle? Well, let's find out. I know that in right triangles, A squared plus B squared equals C squared. And I know C is always the hypotenuse, or the longest side. So when I look at my three measurements, this is the longest side. This is going to be C. And then I can put the legs in any order. Okay. 9 times 9 is 81. 40 times 40 is 1,600. And 41 times 41 is 1,681. Let's add these together. I get 1,681 equals 1,681. This is a true statement. 1,681 does equal 1,681. So this is a true statement. Therefore, this is a right triangle. Okay? So this is a right triangle. Let's do another example. Okay, the book's given us a triangle that looks like this. And they've given us the measurements 18 feet, 12 feet, and 24 feet. And they're asking us, is this a right triangle? Well, a squared plus b squared equals c squared. And c is the hypotenuse. It's the longest side. So when I look at my three sides, this is the longest side, and it will be c. Now we can plug the legs in any order. So 12 times 12 is 144. 18 times 18 is 324. And 24 times 24 is 576. Let's add these together. 468 equals 576. Whoa! 468 most definitely is not equal to 576. This is a false statement. Therefore, this is not a right triangle. So here, we're using the idea of the Pythagorean theorem working for right triangles only to determine whether these triangles are right triangles or not. So if you end up with a true statement, remember, the longest side is the hypotenuse, and that's always C. And if you end up with a true statement, well, then it is a right triangle. But if you end up with a false statement, then it most definitely is not a right triangle. Okay, now we're going to use the Pythagorean theorem to determine the distance between 2 points. So we're going to go back to our coordinate graph. We have a coordinate graph. And on this coordinate graph, I've got 2 points, and I want to know what is the distance between these 2 points. What's the distance between these 2 points? Well, it's going to be kind of hard to figure out because we're going at a diagonal and we don't have perfect lines to count. So it's going to be kind of hard to figure this out. But we do have the Pythagorean theorem that says if we have a right triangle, so I just created a right triangle, that a squared, the side A squared plus b squared will equal c squared. So by creating a right triangle where my line is the hypotenuse, or the longest side, I now have a right triangle and I can use the Pythagorean theorem. So this point is x1, y1, and this point is x2, y2. Now, if we take a look, this point here is the same exact y as this point. It's the same exact y. It's y1. And this point here also is the same exact x as x2. So this point is x2, y1. x2, y1. Okay. Knowing this, I can find the distance of A. A is x2 minus x1. And I can find the distance of B. B is y2 minus y1. And C is what we're looking for, right? So the Pythagorean theorem tells me A squared plus B squared equals C squared. So I'm going to substitute these in, okay? X2 minus X1 squared plus Y2 minus Y1 squared equals C squared. But I don't want C squared. I want just a C. And we're going to call this C, we're going to relabel this C D because we want the distance. So we're relabeling that C D to represent distance. But I don't want D squared. I want only one of these lengths. I don't want the whole square. I just want the length. So I'm going to take the square root of D squared, because now the square root and the square cancel each other. But what I do to one side, I must do to the other. This right here is our distance formula. So the square root and the square cancel each other, and I'm left with D. And the square root of X2 minus X1 squared plus Y2 minus 1 squared. Okay. This is where the distance formula comes from. We are taking our line and creating a right triangle. And by doing that, our X is the same as X2 and our Y is the same as Y1. So with these 3 points, we can now find the distance of A and the distance of B. Well, if we have the distance of A and the distance of B, we can now find the distance of C. So this is where the distance formula comes from. Okay, now what does all of this mean? Let's put it to use. Let's put it to use. Okay, I want to find the distance between 1, 5 and -4, -2. So we have these 2 points. We have 1, 5, -4, -2, and we've drawn our line and we want to know what that distance is. So we're going to create our right triangle. This is the formula right here. So the first thing we need to do is label these numbers, label the numbers, X1, Y1, X2, Y2. My distance formula, let's put that in so that we can substitute. Now I can substitute these numbers here. So the distance is equal to the square root. X2 is -4 minus X1 squared plus Y2 minus Y1 squared. And at this point, it becomes a basic algebra problem. The distance is equal to -4 and -1 is -5 squared. -2 and -5 is -7 squared. Okay. -5 times -5 is 25. And -7 times -7 is 49. So our distance is equal to the square root of 74. And because 74 is not a perfect square, we can leave our answer like this. Okay? You're not going to have to use a calculator to figure this out. You can leave it just like this because 74 is not a perfect square. Okay? So the distance between 1, 5 and negative 4, 2 is the square root of 74 and whatever units they're using. So it could be inches, feet, meters, whatever. It's the square root of 74. Okay, let's do one more. Let's find the distance between -2, -3, and -5, 1. Let's find the distance between -2, -3, and -5, 1. So the first thing I need to do is label my numbers. X1, Y1, X2, Y2. Here's my distance formula. D is equal to the square root of X2 minus X1 squared plus Y2 minus Y1 squared. And now we're going to substitute these numbers into here. D is equal to, distance is equal to the square root. Okay, X2 is -5 minus X1 squared plus Y2 is 1 minus Y1, which is -3 squared. Okay, distance is equal to -5. A negative and a negative is positive. So -5 plus 2 is -3 squared. We have 1 minus a -3. A negative and a negative is positive. So 1 plus 3 is 4 squared. Distance is equal to -3 times -3 is 9. 4 times 4 is 16. Oh, look at this. The distance is equal to the square root of 25. Now, 25 is a perfect square. 25 is a perfect square. It's equal to 5 times 5 or 5 squared. Therefore, the distance is equal to 5, whatever those units are. So in this case, you would need to finish out your square root. You can't leave it like this because 25 is a perfect square. You can take it down to a whole number. Okay? So that's what we're doing today. We are using the Pythagorean theorem to determine whether triangles are right triangles or if they are not right triangles. And when you do this, remember the longest side is always your hypotenuse or your C. The longest side is always the hypotenuse or C when you do this. And then we are also using the Pythagorean theorem to determine the distance between 2 points by creating a right triangle. Okay? So that is what we are doing today.